let's start with our first example of composition of functions. So here's example 1. All right. So let's say f of x is equal to 2x plus 1. And then I say g of x, this is a totally different function, it's equal to 3 minus 4x. All right. So I'm just defining these two functions, f and g, over here. So my first question is, what is f of g? And it's very important that when you write f of g, put brackets around them, of x, right? So what is this equal to? Well, we first start off with, what does this mean? Well, this means f is on the outside, just as we see, and g will now be the input of f. So instead of writing x over here, we're going to write g of x. All right? So what is g of x? Well, we already know what g of x is. It's 3 minus 4x. So instead of writing x here, we're going to replace this with 3 minus 4x. So let me go back here. So let's say f of, put this in red, this is going to be 3 minus 4x. Oops, let me change that last one. So it's 3 minus 4x, and I'm just going to close it with a white bracket there. All right, so what happens next? Well, now the input is no longer x, it's 3 minus 4x. So what happens is that if you recall that when it's f of x, whatever the input here will be replaced by whatever is there. So when we're basically writing this function, it's going to be, well, it's 2 times something plus 1. It's 2 times something. Again, I'm looking at f of x over here. So it's 2 times something plus 1. You might be tempted to say that this is x, but remember, that's incorrect. We're going to replace this by g of x, which is 3 minus 4x, which I've written over here as 3 minus 4x. So I'm going to write 3 minus 4x. And now all we have to do is expand and simplify. So 2 times 3, well, that's 6. 2 times negative 4x, well, that's negative 8x plus 1. And, well, 6 plus 1, that's 7. So it's going to be 7 minus 8x, and we're done. So when I write f of g of x, this is equal to 7 minus 8x, and that's our final answer. Well, what if we did the opposite? What if we wanted to find g of f of x? Will we get the same thing or something different? Well, let's find out. So in the bottom over here, what I'm going to do is I'm going to write, what is g of f of x? So now what we're doing, so I'm just going to put a line to separate the two. Now what we're doing is we're going to say g is on the outside, just as it is over there, and what's on the inside is f of x. So it's f of x over here. So it's the exact opposite from what we had before. Before we were trying to find f of g of x. Now we're trying to find g of f of x. Well, so what goes inside here is f of x. Well, what is f of x? If we observe over here, f of x is 2x plus 1. So when I scroll down here, what I'm going to write first is g, and I'm going to put a space, and I'm going to replace f of x. Well, the function of f of x is simply 2x plus 1. Now what I have to do is I have to look at the function g, because it's g of 2x plus 1. Well, let me look at g. What is g again? G is 3 minus 4x. So whatever you replace with x here should be replaced by over there. So what it's going to be is simply, I'm going to change it to white. So it's going to be 3 minus 4, but instead of x, it's going to be something else. And what is that something? Well, it's 2x plus 1. So it's 2x plus 1. And now what is that equal to? So now we just have to expand and simplify, right? So it's 3, so minus 4 times 2x is minus 8x, and minus 4 times 1 is minus 4. And then if I simplify, 3 minus 4 is negative 1, and then the negative 8x stays there, and we're done. All right? In the next video, I'm going to show you another example of how to do the composition of functions.